Now parallelogram law is also for vector addition. So what do we see in a parallelogram? So let us understand. If there are two adjacent sides of a parallelogram represented by two vectors, then their resultant will go along the diagonal of that parallelogram. Their resultant C will go along the diagonal of that parallelogram. Okay. Now since
Right.
it is a parallelogram, so opposite sides are equal and parallel. So I can also consider this side equal to B. Okay, because they are exactly equal in magnitude and they are parallel also. So I can consider this also as B vector. So
Right.
now I'm mainly focused on this triangle, an obtuse angle triangle, for which I have one of the side as C, the other side is B, and this is A. And since we are just considering a triangle, so I will be mainly taking the magnitudes of those vectors. So this is also assumed that magnitude of vector A is A, magnitude of vector B is B, while magnitude of vector C is C. Okay, it is just an assumption. So as
Okay.
per this triangle, if I want to get a relation for let's say A, B, and C, and what do I have? Let me tell you that as well. If you look at this angle, just try to recall that question. They had given this as 40 degree. Remember?
Yeah.
So since the lines are parallel, I can say this will also be 40 degree. Okay.
Say 180 minus 40.
Exactly. So I will take this angle as 180 minus
140.
theta. 40 was because of that example. I am taking a general case.
Yeah.
So I will be considering that
Okay.
angle as theta.
Alright.
Okay. So 180 minus theta will be the internal angle. Now you have to just focus on that triangle. In this triangle, we have three sides and we need to get relation for ABC. So I can use cosine rule. As per
Yeah.
cosine rule, I know that C square is equal to A square plus B
A
square
square
minus 2AB
minus 2b
cos
cos C.
theta. That is 180 minus theta.
Yeah.
Okay. Are you clear with this
Okay.
formula?
Yes.
Now, cos of 180 minus theta, you can just use your calculator and check it out that for any obtuse angle, cos theta is always negative. So because of that, this cos 180 minus theta will be replaced by negative cos theta. It's just trigonometric part. Okay.
Yeah.
So also one more thing, whenever we do 180 minus theta, this is same as cos theta, but because 180 minus theta is in the second quadrant, we'll put a negative sign. Sine of
Okay.
180 minus theta is sine theta with a positive sign because 180 minus theta is in the second quadrant. And at
Right.
last, if I will write tan of 180 minus theta, then it will be minus tan theta because second quadrant belongs to sine only. So only sine will have a positive value, rest all will have negative values. Okay.
Alright.
So going
Yeah.
back to this, I can replace this cos 180 minus theta with minus cos theta. So I will get C square is equal to A square plus B square plus 2AB cos theta. And finally the value of C will be A square plus B square plus 2AB cos theta. Okay,
Alright.
so you can write this down. This is the magnitude for the resultant. If I just complete this triangle and I consider this angle as alpha. Okay, so this green vertical part will be B sine theta because this is theta. So this will be B sine theta, component of vectors, and this will be B cos theta.
Cos theta.
Okay, so now
Yeah.
look at the whole triangle. For the whole triangle, I have alpha, which I need to find. Why? Because this vector C is making angle alpha with respect to horizontal. In that question, they were asking angle also. Okay, so just look in this triangle. We can find tan alpha is equal to B sine theta over A plus B cos theta. A plus B cos theta and B sine theta. So I'll just write here tan alpha is equal to B sine theta over A plus B cos theta. And I can get the value of alpha by doing tan inverse of that same thing. Okay, so this is how we'll get the angle. For a vector, we should always know how to find magnitude as well as direction. So here we finish this up with whole parallelogram law.